Good afternoon. It's rather a sad reason that we're meeting today, but Geoff, I think throughout my association with him, provided a lot of leadership, and I think there's a lot to celebrate in his life, and I hope to give you one or two insights into what I mean by that, because I worked with him for a number of years. What I want to talk about is really the Bradford System Dynamics group. This is where Geoff really started to put forward his ideas in system dynamics and to translate what he'd learned at MIT from J. Forrester and others, put this into practice in the UK. So this was a groundbreaking group. Now the legacy that comes out of that is, I think, very, very solid for the future. It consists of a number of dimensions and mainly the models. I think during that period at Bradford we produced something like 100 models. Now I know many of you don't perhaps understand, perceive exactly what these models are, and looking at abstract definitions of system dynamics it's very difficult to do that. Now what I intended to do today was to bring all that alive by showing you a model, because I have recreated a model that I first developed when I first went to Bradford University at in Geoff's group. However, we have some technical problems with that, and though I may be able to show you it, it won't come through, I don't think, on the video. So we'll see how time goes as to whether we actually use that development. One or two of you may or may not recognize this picture. This is Pemberton Drive. This is where the Bradford System Dynamics group started out. And this was on the main university campus, or adjacent to the Bradford University main campus. It was actually based and attached to the control engineering department, because much of system dynamics actually comes from that origin. So this house was very familiar to me. Geoff had this very big room at the bottom here, and I had that little tiny room there, up in the attic. This is a broader picture to show you the way that we actually walked, and this is really important, from this house down to the computer center at the university. Why is that important? Simply because we were carrying stacks of punch cards. And when we got there, they had to be punched up and they had to be run on the computer when it wasn't being used for anything else. And it would take a day or so to get a simulation run, a simple simulation run back, only for you to find out that there was some syntax error and it had to all be done again. Anyway, it just actually emphasizes some of the difficulties and the way we were ahead of our time. We were ahead of modeling in general, never mind system dynamics and feedback modeling. Pemberton Drive is located here, and this was this lovely walk that many who are here from that time, like Graham Winch and others, may remember the trip across to the main campus. Shortly after we arrived, we were actually assimilated into the Bradford School of Management, and this is an aerial view of the M Lane campus of Bradford Management Centre. Now, in fact, it is the Bradford School of Management. The only reason for showing you this is that I used to live right adjacent to the campus here, and John Moorcroft later may remember and describe the fact that I used to frighten students because I'd climb over the back wall here and run up to this building, which is where Geoff and the group were established. Let me give you the timeline of this. The group existed from 1970 through to 1992. Geoff was there until 82. I started in 76 and I left in 92. So there was an overlap, and that was a very, very productive time. Geoff, of course, came from his work in the States. I think it was with Arthur D. Little. He visited MIT, and of course he went on to NATO and he went on to Shrivenham. I came from British Coyle, and I went on, as Dan has already alluded to other universities and consultancy groups. The people who were there at Bradford at that time, the academic staff, were of course Geoff, John Sharp, David Price, and myself. Now David and I were research fellows, and John and Geoff were actually academic members of staff. But the main importance of the group was that during that period there were 18 doctoral students and over 10 visiting research staff associated. Now this might not seem a large number in an engineering department. It's really interesting to make this point. But it's in the social sciences and in management to actually teach people a methodology, to get them to develop it into something useful and to actually present a doctorate in that subject. This number of students was a really, really good number to put through. What Geoff did was to actually, based on the MIT System Dynamics group, complete a complete package of activities. He developed software, he developed teaching, he developed doctoral research, grants, modeling, and many conferences we went to. The software was based on the dynamo concept of J. Forrester's, and he produced DISMAP and also the very first DISMod. This was an optimization version of the software that was later developed by Brian Dangerfield and others at Salford University. In teaching, it was the first teaching of system dynamics in the UK, both undergraduate and MBA. There were numerous publications arising from the work. Geoff, if nothing else, was a very prolific writer, as you'll see from the books, and he instilled in everyone, I think, that he worked with the need to document and record. And we produced over 100 models, despite what I've already said about the difficulties of actually creating models in those days. So let me just focus on some of the things that happened: the people, the publications, and the conferences and the models. Now, at the risk of repeating what I once experienced, I think, with Brian Dangerfield at a conference in Japan, where a very senior academic stood up, a professor, and read out just a list of doctoral students, I do want to mention some names. Not only to show you the names, but to show you where they came from and the subjects they did. This was a very cosmopolitan group of students and a very, very wide-ranging field of activity. Graham Winch, who's here today, was a doctoral student working on forecasting. Mazlan Alwani was from Syria and did banking. Dante Montaldo was a metal mining man, and he came from Uruguay. Bob Cavanagh, who you'll be hearing from, I think, I hope, if the technology's working, a little later, was from New Zealand, working on forestry. There were people from Egypt on finance. There were people who I don't even remember what they did here, but remember their countries of origin. From Mexico, from Sri Lanka, from the UK. Again, mining. Kevin Holmes did coal mining. Dave Corbin, who a lot of you here will remember and know, who still works very, very deeply in system dynamics. Juan Rego, Sattar Alalusi, Penendu Mandal, who's still very active, and Kathy Watts. Now, those are the ones I can remember. I'm sure there are one or two more, and if anyone can add to this list, I would be more than interested. Now, not only did we have these internal doctoral students, but we had associate research fellows, visiting faculty. Brian Dangerfield was one of these, Jean Lebal from France, Roger Hall from Canada, John Taylor, who's here today. Eric Mosakuldi, a really important character here in the sense that Eric was very much into chaos and complexity and brought a lot of Geoff's thinking into association with that field. Pratap Mohapatra, similarly, was a control engineer, a fine mathematician who did a lot of work to link what we were doing back to its control engineering origins. Raimo Kalahaju, who was from Finland and very much an optimization man. So he actually did the fundamental work in developing the core parts of this mod, which was the optimization version of the simulation software. John Barton, Sean Chakoval, Michael Karski. Those people come from such a diverse range of countries, and in fact we did talk at one point of having a map on the wall, did we notice, too? So we could actually show just how widespread this group was. So a little bit about people, and secondly, it's something about the publications. I've already said Geoff was a very, very prolific writer. We created our own journal. This was a journal of the Bradford System Dynamics Group, and it was called Dynamica. And the first editor of this was Graham Winch, who's here today. And I was the second editor. I think I took this over when it was 3 or 4 years into its life. It lasted between 1975 and 1984. It consisted of 23 editions and 120 papers, many of which, most of which, were internal papers on the research we were doing. It eventually, Dynamica became the journal of the System Dynamics Society, the System Dynamics Review, which I'm sure you're all familiar with today. And I was the first editor of that System Dynamics Review. And the contributors to it at that time in Bradford were really a who's who of the current field of system dynamics internationally. And I just throw some names at you there that you may or may not be familiar with, but I'm sure Peter Senge and John Sturman and Eric Mosakodi. And lastly, very importantly, Donella Meadows, who sadly died a few years ago, but was really a very, very important person in the development of the softer versions of systems thinking. Okay, in addition, we went to lots of conferences. I've got lots of anecdotes there, but I don't think I've really got enough time to do justice to all those. We certainly had a presence at all the early European and American conferences in systems. And a wide-ranging set of systems ideas it was, not just system dynamics, but all the associated parts of chaos and complexity that came with that. We contributed as a group quite substantially to the formation of the System Dynamics Society in 1985. We sent a large delegation to a conference held at the University of Albany in the States, where in fact the International Society was created. So Geoff and the group were very, very important in bringing together the British ideas and the American ideas of system dynamics. I won't try to describe the subtlety of the differences there, but there were some. So what did all that mean for Geoff's achievements? First of all, his stature. Geoff was an academic leader, an entrepreneur, and a pioneer. He did things his own way, and he did them extremely well and in a lot of detail. He's what I would describe as one of the first truly business academics. That's people who really don't do things for the sake of the research, but do it to change the world. He wasn't interested unless the results were actually practical and useful. He created a group that in many, many ways was ahead of its time. Just to put one point on that, by 1980, having been assimilated into the management school at the university only 2 years before, the group was producing more doctorates and research papers than the rest of that embryonic centre put together. And this is talking about a seriously highly rated institution. The focus was really on output. He developed an international reputation for himself and for the group. We ran courses all over the world. I remember one in particular in Indonesia, that he and I ran for the Navy, in fact, in Indonesia, in Jakarta, where they decided we were really professors and they should feed us on brains, and we had brains for lunch every day for a week. He got the first Lifetime Achievement Award of the System Dynamics Society. I think that was 1998. Do anybody correct me if these dates don't quite tie in?
96, wasn't it?
96. Okay. Any further officers? 96 to you. And of course he established this chapter, the UK chapter of the System Dynamics Society. So what does all that really add up to? I think it adds up to a suite of models that we created that really are important and should be recreated. This point is really fundamental. Not only were the models ahead of their time, remember this is a time when spreadsheets weren't really used very much at all, but the whole concept of simulation modeling was ahead of its time. So there were no desktop computers. They were only just arriving. There was certainly working with DOS. There was no Windows. Apple's interface really came a few years later, in about early 80s. So this was before a lot of what we now take for granted, and a lot of which makes life easy to do modeling. So I really make this point to you, that Geoff managed to create a level of output and stimulation, as well as simulation, that was really way ahead of what other people were doing. Now, Dynamica is our path into that. A lot of the models don't exist any longer, but Dynamica has, again, due to the efforts of Graham Winch, that's all been placed on the International Society website. And anyone wanting to chase up any models that were created during this period will find many papers in the Dynamica archives on that website. And the other thing, of course, were the people that he inspired around the world. Now, my dilemma is whether I actually show you a glimpse of a model, because this is not a static subject. This is the sort of subject that only comes alive when you see a model. So I will do a very, very brief demonstration of a model I first created when I first went to Bradford, which was of the copper industry, the copper market. Very simply, it consists of a supply chain. Ore is mined, it goes into a mine stock, and it's just sold on through refiners and through the market, and is consumed. And one of J. Forrester's big contributions to this subject was what's called the bullwhip effect, the way that supply chains amplify consumption movements right up the chain. So everybody wants more stock up the chain, and they all actually try to satisfy their own stock coverage. But what we did at that time, interestingly, was to also say that price was a major determinant of what happened to production and consumption. And we formulated a price within a model, which was really the ratio of just where people wanted their desired stock coverage in the industry and where it was actually at. So the price would be self-generated and would in turn feed back to affect consumption and production. So a very, very simple model. I can describe this on one sheet of paper. It can be changed in many ways. It can be replicated. We could look at many different suppliers through the supply chain. We could look at many different countries through the supply chain. But what I will just show you briefly is really what is the magic of system dynamics. Here we have an output from a model created on the basis that I've just shown you. It's not a complicated model, and if I run it, we'll simply find that we get the consumption input that we've made. So this doesn't generate consumption. Consumption is placed on this model from the outside. But what we're really interested in is how, through time lags and up along the supply chain, how that particular consumption is responded to. So the red line here is the way that production has shifted to try and actually catch up and keep in phase. So it's very much control engineering, how one line tries to keep in phase with another. The purple line I now superimpose is what's happening to the stocks through the market. And we can go on. I can show you, next one would be the way that price is created through the market. And a model like this, although generic, can be parameterized to a whole range of different types of minerals or indeed different sorts of commodities. And what I did at that time was to work very much in terms of copper. So this is like a magical dynamic cobweb model, as the economic people would call it, where you have consumption and you have, which is demand, and you have production, which is trying to follow that, and it's trying to do it around almost a cobweb over time. So people are ordering, they're generating eventually a production response, and the price is an outcome from that. And that sort of simple model can be used in many, many different dimensions to show the effects of things like selling strategic stockpiles on the market, using buffer stocks, and indeed to look at the dynamic effects of simply changing production lags. If we knew what was going on faster, what would happen? We would get more instability. If we could respond, not only use that information, but respond to it, we could create more stability. But if we had bad investments, we'd get instabilities creeping in yet again. And by bad investments, I mean investments that don't come on stream when they're meant to come on stream, don't come on because of delays, and because of the fact that the ore grade isn't good enough, etc. I really just wanted to give you that flavor of a model as to what this is really all about, because there were lots of these models and they create insights. They create tremendous insights because they usually, because of feedback and time delays, create counterintuitive behavior. They don't perform like you might expect an economic model to perform. They do to a degree, but I'll just give you, if you bear with me, one simple example of this. And that's to go back to my original model and run that. And just to show you the effect of switching on the sales of a strategic stockpile during this period of the model. So what's going to happen? If we sell big stockpiles onto the market, economists would tell us the price is going to collapse. Does that indeed happen? Remember, there was a big peak here. What happens? That peak gets shifted along. I can show you this better here. Number one was the original peak. This is the period over which the stockpile was sold. It brings the price down, but there's a kickback. There's an unintended consequence. We control the price for a while, but then it amplifies again. So, whereas straightforward economics would look at a point-in-time situation, this actually looks at what is the unintended, delayed consequences of actually making strategic change. It's interesting because number one there was where we had no stocks going on the market. This was the stockpile being dumped. And interestingly, the stock gets smaller. Having put that stock on the market, stocks then generally will go down. So why is that? You've got to remember that what we're doing is affecting consumption and production. So putting a stock on the market does behave like the economists would suggest, except that later we get consumption going up because the price came down, and we get production being stagnated. And when those come back on stream, they give us subsequent rises. That may prove no more interesting than an abstract definition of system dynamics, but those models always come up with some certain effects. They're rich in dynamic complexity, feedback and time lags. They join up operational models, which all companies have. They're richer and more transparent and flexible than spreadsheets, but more importantly, they provide counterintuitive learning as much as forecasting. And I would say that's true of many of the models that we produced at the time. And if anybody wants to look at sources of information on this, a number of people have worked on mining and commodity models, and the Society's website contains a bibliography and an archive that relates to all of that. Right, one moment for final words. Working with Geoff at Bradford changed my life, undoubtedly. It unleashed my curiosity. It was a new way of thinking, and if any of you really feel that your thinking is not being nourished, not being developed in the way you feel it should, a dose of this sort of thinking forces you into a level of thinking that certainly I hadn't previously come across. The practical approach to use was a basis for my later consulting career, and perhaps the biggest legacy for me is that I still live in the Bradford area. So my children have been brought up in that area because of my move to that area on the back of what Geoff was doing. It was a pleasure to work with him, and I think we need a lot more people like him. Thank you very much.